Okay, I'll have to do it in a Word document format, which kind of sucks, but we'll get it done. Okay, so we don't have a lot of time left here. We'll get a little bit of this booklet done. So 3 types of velocities that we're going to consider, and they are constant velocity, average velocity, and instantaneous velocity. Okay, and so the reason that I did that little math review was because the first one that I'm going to do is I'm going to talk about constant velocity. Okay, and I really need kids to understand sort of the different types of velocities and what's going on. Okay, so here's an example. You're driving down a highway. You notice that it takes equal intervals of time to travel between hydropoles. This is an indication that you are traveling at a constant velocity, and there's the formula that we've seen already for determining constant velocity is V bar equals d over t, okay? So V bar means average velocity, but if you're traveling at a constant velocity, then your average is going to be the same as that velocity, the constant, right? The average is always going to be the same as all the other velocities. So V is velocity in meters per second, kilometers an hour, d is displacement in meters, kilometers, etc., and t is time intervals, right? Note that since displacement is either positive or negative, velocity will have the same directional rotation, okay? You should have some positive, you should have some negative velocities. Similarity in sign for both velocity and displacement occurs because time must always be positive. Time is not a vector. Okay, so here are 1, 2, 3, 4, 5 practice questions, very similar to the ones we just did. The only difference being is in the ones we just did, I gave you V equals, D equals, and so for this, right? I didn't do that here. You need to do a little bit more thinking, okay? So questions 1, 2, 3, 4, and 5. You might want to, there's a fair bit of space here, you might want to just use the left-hand side of the space so that if you've made a mistake, then you can correct it and leave a little bit of space. So how about we just try numbers 1 and 2, and I'll give you the answers right away. Okay, let's have a look at these. What's the constant velocity of an airplane that flies 602 meters east in 2.5 seconds? Express your answer in meters per second and in kilometers per hour. The solution is important, you guys. The answer is only worth likely 1/3 of the mark. Okay? The solution is important. I don't care about just the answer. Okay? And as you get farther along, especially in grade 12, when you get a 10-mark question, the answer is only worth 1/10. Okay? You need to show me the process. So I'm going to write V bar equals d over t. Okay? And then I'm going to write 602 divided by 2.5, and then I'm going to write the answer. All those parts are important. Remember your calculator time? I probably have the answer somewhere, actually. How about I just do that? I'll just go find my answer. There we go. Okay? So you should have an answer of 240.8 meters per second. Okay? I need to see meters per second, I need to see the formula, and I need to see the substitution. And I'd like the equal signs to be lined up. Okay? It's important. It gets more and more and more important. Because as I said, when I see that 10-mark question, and I just got numbers all over the place, I got no idea what to do. Okay? I'm trying to train you here. I got to see it in kilometers an hour as well, so you're going to write 240.8, and you're going to multiply by 3.6 and show me 867 kilometers per hour. Okay? Number 2 there, the tine on a tuning fork moves 1 millimeter to the right in 4.0 times 10 to the minus 3 seconds. What is the constant velocity of the tine in meters per second? The tine is the little pokey thing. Like on a regular fork, it's the pokey thing. They're called tines. That's the technical term for it, pokey thing. Okay, now, did anyone notice that the distance is in millimeters?
Yeah.
But I've asked for it in meters per second, so you're going to have to convert millimeters to meters, right? How do we do that? Now we're going to have a bigger number than 1 or a smaller number than 1? Smaller number than 1, right? So I'm going to move my decimal place. Well, I was looking for direction, but you're right. 3 places to the left. How do you know it's 3? Nick, how do you know it's 3? There's 10 millimeters. Okay. 10 milli means 3 minus 3, right? Times 10 to the minus 3. There's 10 millimeters in 1 centimeter, and there's 100 centimeters in 1 meter. So to get from millimeters to meters, I've got 1, 2, 3 zeros, which is 3 moves to the left. So that's 0.001 meters, right? 1, 2, 3. I was at 1, and I went 1, 2, 3 left. So now I'm going to write V bar equals D over T. And now I'm going to write 0.001 all over 4 times 10 to the minus 3. And I get 0.25 meters per second. Then how many people went on to the next slide? An electron travels at a constant velocity of 1.3 times 10 to the 5 meters per second. How much time is required for a displacement of 1 meter? V bar equals D over T. This time I have the velocity, 1.3 times 10 to the 5. My displacement is 1. Solve for T. T equals 1 divided by 1.3 times 10 to the 5. 7.69 times 10 to the minus 6. If you think to yourself, oh, I can't believe I'm going to have to write formulas for the next 2 semesters, grade 11 and grade 12 physics. Think about how many semesters I've had to write the formulas out. A lot more. Write the formulas out. I'll be writing it on your test. Write the formulas out. A spaceship travels at a uniform velocity of, what does uniform velocity mean? Same, constant. Yeah, uniform means constant. 3.2 times 10 to the 4 kilometers per hour for 2.7 days. What is the displacement of the spaceship? Do you have to do anything with the days? Because my speed is measured in kilometers per hour. So I got to take my 2.7 days and do what? Multiply by 24 hours. And then I'm going to go V bar equals D over T. My speed is 3.2 times 10 to the 4. I'm looking for displacement. What's 2.7 times 24? Can someone help me out there? 48. It's like, how much? 64.8? That sounds vaguely familiar. So my displacement is going to be 64.8 times 3.2 times 10 to the 4. And my answer is 2.07 times 10 to the 6 kilometers. Your answer should always be in the sort of bottom right-hand corner. That's where I look for answers. 2.07 times 10 to the 6. What about number 5? What's the trick in number 5? Yeah, you got to either switch 85 kilometers per hour to meters per second or switch 200 meters to kilometers. What do you want to do? Oh, it says how many seconds, so I should probably convert my 85. Divide by 3.6 is 23.6, right? And now we go V bar equals D over T. 23.6 to 100 divided by T. And you should get 8.5 seconds. All right, I will call it a day there. Okay? We will finish off that booklet tomorrow.
I'll call it a day too.
Yeah?
Like the rest of the day.
Oh.